So in this class, we are going to talk about 5 equivalent things, okay? We've covered 2 of the same thing before. As I always said, the fractions are the same as divisions. The divisions are the same as fractions, okay? Then today we are diving into a more detail of that. So what are those 5 equivalent things? The first thing, so we talked about the division. Then it is the same thing as fractions, right? And we have decimals. And I believe you guys have learned how to convert fractions to decimals already, right? So they are equivalent. They are the same. What next? Probably let me move decimal to here. So decimals are the same as fractions. And it is the same thing as what you just learned, those 2 things, the percentage. And we are adding one more thing, which is the ratio, okay? These 5 things are the same. And what's the function, or how do we use them, or in which occasion we are gonna use them, okay? Today we are gonna talk about this. So first, what is a division? Division, it's an operation, okay? It's an operation. What does division do? What does division do? Basically, we can use division to do 2 things, okay? One thing is we divide, right? That's what we learned first. Division help us to divide things equally, evenly, between like number of groups. We divide 100, or like, let's say if I have 100 candies, I want to divide them. I want to share with my students. Let's say I have 10 students. So how do I make sure everybody receive the same amount of candy? I do divide, right? I do 100 divided by 10. So the first thing is to find how many things that I need to give if I'm sharing, right? I need to give each one 100 divided by 10 equals to 10. I need to give each of the students 10 candies. So the first thing we can do with divisions is divide. Second thing, it's the division could help us to find how many divisors are there in the dividend. Okay, this is the second thing that division could help us to do. How many divisors are there in the dividend? So a lot of times we are trying to find, let's say, let me create an occasion. So okay, so I have a task which should require, or let's say the military have a mission to do, which requires, let's say, 100 soldiers to complete. But the soldiers, like, they come in groups, like a small units, which every unit contains 2 soldiers. Then how many units this military have to send out for that task? It requires 100 soldiers in total, but the soldiers come in 2 in a unit, right? In a small unit, because they have to cover each other's back. So 2 in a unit. Then how many units are we gonna have, or are we gonna need in order to complete those tasks? That task. So we are trying to find how many 2s are there in 100, right? This is what we mean by finding how many divisors are there in the dividend. Okay, just a quick refresh. So in the division, we give a name to every single place of the number. So let's say 6 divided by, let me write it in hand. So 6 divided by 3 equals to 2. We give a name to every single number. So this one is what we call dividend. And then this is what we call a divisor. And then lastly, the answer to the division, we call it the quotient, okay? Because every number have a special name. So you know what I'm talking about. When I say division, when I say dividend, you know I'm referring to the first number, right? The number that needed to be divided. When I talk about, okay, so this the divisor, then you know, okay, that's the 3. Good? That's why we give a name to every single number. So this is for the division. Then let's talk about the decimals and the fractions. What are those? What are these two? What are they? These two are the result of division. Okay? They are the results. They are the results of division. So when I ask you, okay, what is 2 divided by 3? Or what is 1 divided by 2? What is 1 divided by 2? Let me write this here. So give you an example. So let's say 1. Let's say will be a good one. Let's do 3 divided by 4. So for a division, it could be 3 divided by 4, right? That's a division. Then if I ask you, okay, what is the result? What is 3 divided by 4? Then I will accept this two form as the answer. 3 divided by 4. For decimal, it's 0.75, right? Or 75 hundredths, okay? 75 hundredths. Or we can just write as the fraction, which is convert directly from the division, which is 3 over 4. Good. So these two are the results of divisions. Why do we, so first we actually have the decimals. That's based on the decimal system. That's what we expanded before, right? It's based on 10. After every 10 numbers, we move to the next place, and then we reset the current place to the smallest number, which is 0, right? We add 1 to the next one. So for every 10 numbers. So that's for the decimal. But why do we need fractions? Because check it here, for the decimals, in order to find 3 divided by 4, we have to do some calculations, right? This is what we do. We do the vertical methods of the fractions, or long division, right? We do long divisions. So we are gonna do 0 point because 3 is smaller than 4. So this is 7, which is 28. Then this is 20, and we go 5, right? 20, we have nothing left. This is how we find the result by using the decimal format. But there is a much faster way, much easier. There's no calculation required. We just rewrite 3 divided by 4 we can just rewrite it and we got the answer instantly, right? 3 divided by 4, we put the dividend as the numerator, 3 over 4. This is also, we can accept this as a result of 3 divided by 4 as well. And we got the result right away just by rewrite the division, which is very convenient, right? Okay, so that's for the fraction. We can just rewrite. Okay, then why do we need decimal? Why? Because fractions are so convenient. Why do we still use decimals? So then I'm gonna give you different occasions that we're gonna use division. We are gonna use fractions and decimals. Okay, we use them under different occasions. So for the decimals, decimals are the best for 3 things: addition, subtraction, and comparison. Okay, I'm just gonna skip that. Okay, so the fractions are the best for addition, subtraction, and comparison. Those 3 things. For example, okay, for example, let's say 1/4 plus, let's say 1/5. This is addition for fraction. Is that easy? No, right? We can't do it directly. We will have to convert these 2 fractions to like fractions. So we need to find the least common multiple of these 2 numbers to put as the denominator, which is 20. Then we need to convert the numerator as well. So this is 5 plus 4 over 20. Then this is how we got, right? How we got the answer, 9 over 20. We have to find the LCM, then do multiplication for the numerator, 5 and 4. Then lastly, we have to do addition. There are a lot of steps. But what if we're doing the decimals? What is 1/4? It's 0, that's 25 hundredths, right? What is 1/5? That's 0.2, which is 2 tenths. How do we add it? Very, very easy. It's just like the normal addition, right? We get so used. That's what we used to do. This is very easy. We just rearrange it so that it's aligned by the left. So we add the 2 with a 2, which is 0.45, 45 hundredths, then done. See here? This is what I mean by it is better for addition, subtractions. Subtractions is the same thing. We could just simply do this, right? Then again, you will have to do subtraction. Then again, you need to do one more step. But for subtractions, it's apparently, I can figure this out by just looking at it, right? It's 0.05. Done. So decimals are better ways usually, okay? Usually, we have some special cases that decimal are not better, okay? But usually, okay? Usually, decimals are better for addition, subtraction, and comparisons, okay? For comparisons, this is easy as well, okay? To compare this two, it's pretty easy because we have the same numerator. But what if we have different numerator? Let's say 4 over 3 and then this 4 over 5. How do you compare this two? It's not easy, right? Yeah, I mean, we could apparently we could use special methods to compare, because what left in here is 1/4 and what left in there is 1/5. And apparently the leftovers for 1/4 is larger, which means this is larger, right? But it requires a special method. But usually how do we compare these two is by same thing, making them to alike fractions. 3 divided by 4, 3/4, that is 15/20. Then this is 16/20. See, slightly larger. So we know this is larger, right? It requires a lot of, again, a lot of steps. But by comparing the decimals, it's quite easy. This is 0.75, and this is 8. You can just, by looking at it, right, by the place value, you got the answer right away just by looking at those two decimal numbers. This is what I mean by addition, subtraction, comparisons. Usually we like to use decimals, okay? Then that's why the fractions are so convenient, but we still use decimals, okay? We do everything for a reason. Then let's move on to fractions. So what are the fractions best for? They are best for, see, we've learned 4 operations. Besides addition and subtraction, we have division and multiplication, right? So they are, yeah, make your best guess. They are better for division and multiplications, right? They are good for these two things. Yeah, okay. Why? Okay, let's use the same examples. So 1/4, let's do 3, what did we do? We had 1/4 times 1/5. Let's do that, okay? This is pretty easy. We do numerator times numerator, denominators times denominators. Then this is 4 times 5, 1/20, done, right? Pretty easy. We do 1 times 1, 4 times 5. So 2 multiplications, then done. But for decimals, it could be very difficult, okay? This is 0.2. This is 25 times 0.2. Okay, this one is not very hard, but it could be, but basically we have to win actual miles to get the answer, right? We have to do extra steps. So this is 0.25 times that. And then we need to figure out, this is easy because 2 times 25 is 1 digit times 2 digit. But some of the decimals or some of the fractions, it could be like much longer. So in this case, we know it's 5, but then we still need to figure out the place, right? How many place do we move the decimals? The answer is 50. Then we shift it to 1, 1, 2. So we need to go 1, 2, 3. See, more steps. Okay. So usually, again, usually we have special case. Okay. So usually fractions are the best for divisions and multiplications. It is not good for comparison, right? We already give the reasons. And then let's move on to the next thing, which is percentage. What is the percentage? Percentage is a special kind of fraction, okay? So first, you need to understand percentage is a special kind of fractions. So it's a special fraction. Special fractions with 100 as its denominator, okay? This is a special fractions. So basically how to do this is 3/4. hopefully you guys still remember how do we do the equivalent fractions, okay? We need to convert this 3/4 to something over 100 in order to convert that into a percentage. So 4 to 100, it's times 25. So the numerator have to keep the same relationship, which is times 25 as well, okay? So this is what we find, 75 over 100. Then we rewrite the fractions. We have a percentage sign, basically means something over 100. Okay, we have a percentage sign, basically means something over 100. So this is 75 over 100. We write it as 75%. Okay, this is the percentage. Percentage is a special kind of fraction with 100 as its denominator. Good. And this is how we convert the fractions to a decimal. We need to have this. We need to convert the fractions to 100 as its to use the 100 as its denominator first. Then we convert it to, then we rewrite with the percentage sign. Yep. Okay. Then converting from decimals is pretty easy because divided by 100, basically you move the decimals to the right by 2, right? So 0.75 is 75%. You have the number right away, okay? So converting from decimal to a percentage are much easier, which we are not gonna cover today. We've talked about this before, right? And then what do we use the percentage for? These two are actually used for, let me move this down a little bit. Okay. So this is what the percentage is, and we use this tool. These two are showing the relationships between two numbers, okay? They are the relationship two numbers or things, okay? This could be more, two could be more. We are going to talk about them. So these two are showing the relationship. These two are not the results of division. Those two are the relationship between two numbers, okay? Both of them are the relationship. So what is the difference? So let me give you, so this ratio is 3:4, or the relationship, this might be better. So just relationship between two things, okay? So when are we going to use percentage and when are we going to use the ratio? This is how, okay? The percentage is one thing compared to itself, but under different time or under different situation. Let's say, okay, we are analyzing the revenue for a company, okay? But we are trying to see the growth rate for that company. So what are we trying to compare? We are trying to compare the same company, right? But with different years. So we are trying to find a growth rate. So we are comparing this year with probably last year or, previous years, like the years before. So the percentage is comparing same thing. But under different time or for situations. Okay. Okay, so we are comparing the same thing. We are comparing yourself to yourself, you to yourself. Okay, like okay, so uh how tall are you like this year comparing to last year? So the fraction, what we are comparing to, we put it as the denominator. Okay, so if we are comparing last year to this year, then we put this year as the denominator, and we put last year as the numerator. Then we convert the fraction to 100%. So this is a better way to show the relationships, to show the growth, to show the comparison between like last year to this year, or like okay, so you're running the same company. I mean, in our assumption, so let's assume you run a company for 1 year, and then the other guy runs the company for another year. This see is under different situations, because you run the company and he runs the company, and then all other criteria are the same under the same economic conditions, under the everything is the same except you run the company and he run the company. Then we are comparing him and you, right? So this is the comparison between the same thing but in different situation or different times. But for the ratio, this is when we are comparing or shows the relationship, okay? Shows the relationship between two different things. Two or more, okay? So for ratio, this is a very special thing for a ratio. Although they are equivalent, but there's something that only ratio has, okay? Ratio can be more number or more things. Everything else you can only do two, okay? Division, you only do two at a time. You can do 2 divided by 4, then divided by 5, but we have to do 2 at a time. But ratio, you could have 2 or more things, okay? Different, okay? Different things. See, percentage is you comparing to yourself, but for ratio, it's like, for example, most commonly used the ratio is for the recipes. Okay, so let's say I have a recipe for let's say milk tea. So I'm taking 1 cup of milk with I'm just making this up. Okay, don't do that. So or let me see if I have any recipe. No, okay. So let's say I'm making milk tea. Okay, don't do that. So I'm putting let's say 4 cups of green tea, and then putting 4 cups of green tea, and then 1 cup of milk. So 4 is the green tea. So let's say I'm making one portion, or I'm selling those milk tea by containers. Okay, so in order to make 1 container, I need to use 4 cups of green tea, and I use 1 cup of milk, and then probably I have to put let's say syrups. So probably let's what kind of syrup? Maple syrup maybe. Or let's say we could have like different things under different measuring unit. So let's put sugar. Okay, I don't like it to be uh, very sweet. So let's just do 2 grams maybe. So this is cup, this is cup, and this is 2 gram. Okay, so see here, we use the ratio to show the relationship between green tea, milk, and sugar. This is the amount we need to use to make 1 container. What if I have more? Okay, so I have 10 customers coming in at the same time, and I have to make 10, make 10 container of that, right? I'm not gonna make it one by one, it takes longer. So I'm gonna make 10 at the same time all together. So how do we do that? We use the ratio, okay? This is the ratio for one container, okay? This is one container. They increase at the same time. The relationship, everything we show here is either multiplication or division relationship. So in order to get 10 container, now see here, I increase the amount. I increase the amount from 1 to 10. From 1 to 10, what's the relationship? It's multiplied by 10. So we also have the equivalent ratio. Equivalent ratio. It's exact the same thing as exact the same method we use to calculate the equivalent fractions. Okay. The relationship between 1 and 10 is times 10. So we do keep all the numbers the same relation. So 4 cups now increase to 40 cups. Then milk, 1 cup increase to 10 cups, right? And 2 grams of sugar now is 20. See here, this is how we find the ratio. And ratios are so special. It can be 2 or more things. See, we have 4 different things. One is the container. The first one is container. I don't have place to write it, okay? So the first one is container. Second one is the green tea. Third one is milk. And the last one is the sugar. It shows the relationship between 1, 2, 3, 4, 4 things, okay? But for percentage fractions, it can only be 2 things, okay? For decimal or fractions, we can do more things like the fractions over a fraction, but that would be, special. Or divisions, usually we only do 2 at a time, okay? But for the ratio, we do multiple things. We can do more than 2, okay? So those are the 5 equivalent things. And when are we gonna use each of them? And what are each of them? What are those things? Okay, and when could we use them? What are the best occasions to use them? Okay, good.